Welcome to this lesson on torque, one of the fundamental concepts in rotational motion. Torque is what causes objects to rotate, spin, or turn. Just as force causes linear motion, torque causes rotational motion. Understanding torque is essential for analyzing everything from simple machines to complex mechanical systems. So what exactly is torque? Torque is the turning effect of a force applied at a distance from an axis of rotation. Think about opening a door. When you push the door near the handle, far from the hinges, it opens easily. That turning effect you create is torque. The farther you push from the hinges, the easier it is to rotate the door. The mathematical formula for torque is tau equals r cross F here. Tau, represented by the Greek letter, is the torque. The variable r represents the distance from the axis of rotation to where the force is applied, and F is the magnitude of the applied force. This formula tells us that torque depends on both the force and where that force is applied. Torque is actually a vector quantity, which means it has both magnitude and direction. The formula tau equals r cross F uses the cross product symbol, indicating that torque is the vector cross product of the position vector r and the force vector, F. This cross product operation is what gives torque its directional property, making it perpendicular to both the position and force vectors. The magnitude of torque can be calculated using the formula tau equals rf sine theta. This expands our understanding by showing that three factors determine how much torque is produced. First, the magnitude of the force F. Second, the distance from the axis r, and third, the angle theta between the position vector and force vector. Maximum torque occurs when the force is applied perpendicular to the position vector, where sine theta equals 1. The direction of torque is determined using the right-hand rule. Because torque is a cross product, its direction is perpendicular to both the position vector and the force vector. Point your fingers in the direction of r, curl them toward F, and your thumb points in the direction of the torque vector. This perpendicular nature is a key characteristic of all cross products in physics. Torque is measured in units that combine force and distance. In the SI system, the standard unit is the Newton meter. Abbreviated as N.m, this makes sense because torque equals force times distance. In the imperial system, torque is measured in pound-feet. Abbreviated as lb.ft, these units reflect the fundamental relationship between force and lever arm distance. Torque appears everywhere in daily life. Opening a door involves applying torque around the door's hinges. Tightening a bolt with a wrench uses torque to create rotational force. Turning a steering wheel applies torque to change the direction of your vehicle. Even a seesaw demonstrates torque, where the balance depends on the forces and distances on each side of the pivot point. Understanding torque helps us analyze all these rotational situations.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.